So, for those of you who are, what, green group? Yeah, it's blue today. Sorry, I got socks on telling me what day of class it is. I'm not even joking. For those of you who are green group and will be at school tomorrow with Mr. Johnson as your substitute, all you got to do is watch the lesson, take the notes as we go. I know this is weird, but it's actually what your classmates in the blue group have been doing since we have 8 of us versus 2 of us in those groups. So here's our announcements. I will be gone tomorrow, or if you're watching this on the 15th, I am currently gone today. Graph paper and pencil, you're going to need that as you watch the video, and you guys already have it out, so thank you very much. Today we're continuing to discuss what we talked about yesterday, graphing quadratics in standard form. Then we're going to talk about throwing things off of buildings. And then we're going to talk about graphing by hand from any form that we have, which of course we can still use technology, but we're going to not typing the graph, not typing the quadratic into Desmos and saying, look, I graphed it. Actually building the graph on our own. No school for anybody on Friday, right? Do not come to school. Nobody will be here. The day is off because of conferences, right? So we have conferences next week, so they give us Friday off. Homework is still due on Friday, and I will assign new work on either tomorrow or Friday. Certain people are done with their work and asking, when are you going to assign the new work? And I'm trying to get people caught up first. I don't want to stack your Khan Academy with way too much work. And if we have time, we'll play a game in Desmos. I will probably assign it to the class. So even people watching this tomorrow, which will be today for you, if you go into Desmos and log in, it should be there assigned. So this is the problem that we didn't get to yesterday. We ended with the problem that had a leading coefficient of 1/8, right? So now kind of contrary to that, or the flip of that, having the leading coefficient be 8 is going to make this behave differently. So let's try to remember what we said yesterday. So let's write down, first off, a header for our notes. What should we head this? Graphing, just graphing. I mean, today's mainly going to be about graphing. So, graphing, I know you can't see my camera. Graphing, just like quadratics pretty much, right? You guys should go ahead and write down that quadratic that's up there. Today is the 14th, unless you're watching this tomorrow, and then it's the 15th. And 8x squared plus 16x plus 3. We're just going to do one of these and then go review other things. So even if we thought about some of the other easier things that we can do, like get rid of the leading coefficient by dividing by 8, that wouldn't be so nice when we look at our constant. Sorry, I'm teaching class right now. I'll have the last 10 minutes of AO available, but aside from that, just email me and we can set up for extensions. We might just have to do extensions. Sorry, I need to get 7th grade to realize that although eHall Pass shows me as available, I'm teaching a class. So this is kind of messy if we try to get this leading coefficient to be 1. So yesterday we said we know some equation for what x equals. And x of the vertex, right? So if we're talking about the vertex, we have some equation. What was that equation? It's part of the song. That is our perfect square form when we, or actually that's vertex form of perfect squares. So we talked about this comparison yesterday of x plus or minus c, but this is what we're looking for, is this important equation of x equals negative b over 2a, which us not being able to remember that tells me we need to practice that a little bit. So if x equals negative b over 2 times a, then the opposite of b So negative 16 over 2 times, well, a is 8. So negative 16 over 16, negative 1. What do we do now that we have our x? And actually, guys, if you haven't watched yesterday's video yet, you need to, right? Because you guys weren't in class. So if you haven't gotten a chance to watch yesterday's video yet, please go back and do that. If you have watched the video, then I would hope that you know what we do next. But if you don't, that's my job. So let's just have you guys watched the video or no? It's okay if you haven't, but. Okay, so I will teach this, which is totally fine. So now that we found the x of our vertex, we want to find the y, right? So we say, well, what does y equal? Well, we know y equals, sorry, that's a question mark, but it's a bad one because my pen got kind of caught up. Y equals our function, right? 8x squared plus 16x plus 3. But, and I'm not going to write over here because I don't have enough space, we now know what x is. So if we say, well, y is 8x squared plus 16x plus 3. Well, really, it's 8 times negative 1 squared plus 16 times negative 1 plus 3. So we're plugging in the x that we found from the equation for x of negative b over 2a. So this now becomes 8 times a 1 plus a negative 16 plus a 3. And that's 8 plus 3. So our positives together are 11 plus a negative 16, because I brought my 3 over and put it with my 8. So the negatives are going to win here, and y is going to equal, just shout it out, guys. So it only squares the x. So I appreciate you asking that, and that's something that we actually talked about yesterday. So like I said, go watch that video. Only the x gets squared because, remember, order of operations tells us that powers come before multiplication, and this is multiplication. The only way that we would square both is if it was written quantity 8x squared. So if it was written, that is not the same as this, because this says square x then multiply by 8. This says multiply by 8 then square it. Does that make sense? So yeah, here it's just 8 times x squared. So the negative 1 squared was positive 1. And that's how we got down to here. The 8 and 3 made our 11. And we get negative 5, right? Because negative 16 plus 11. So now we know that our vertex is negative 1, negative 5. So if we were thinking about graphing this, and let's go ahead and graph this one because it's what we're going to be practicing all day. If you want to make a set of axes that you'll use for everything, that's totally fine. I'm probably going to make new axes for each problem. Because this is negative 1, negative 5, I'm going to push this axis up a little bit. So negative 1, negative 5, 1, 2, 3, 4, 5. Here's my vertex. Now the other thing that I can tell from looking at the parabola or the quadratic when we start, it's going to face upward because it's a positive 8x. So guys, here's the trick that yesterday it took us a minute to get to and we kind of stumbled over a tiny bit. So when you go watch the video, you'll see that. If this is the vertex, I told them to choose another point to find, but because parabolas are symmetric, we know that there's a line of symmetry going straight through that vertex. So all we have to do is go one direction and then reflect those points across the line of symmetry. So if we go to the right and start to try to build our parabola that direction, then we're going to go from negative 1 to just 0, right? So we know When x is -1, y is -5. But let's try when x is 0, what is y? And we can either use a calculator or off to the side on paper, or if it's easy enough to do in our head. And because we're using 0, this might be easy enough to do in our head. 0 squared, 0. 8 times 0, 0. 16 times 0, 0. Oh yeah, when x is 0, we just get the y-intercept. +3. Okay. What that also means is on the other side of our line of reflection, we also have a +3. So, if I know 0, I also know -2. Then, and these don't have to be in order. It would be nicer if they were in order. So a lot of times we would put our vertex in the middle of this table and then work up and down. If I go one more point to the right or one more point to the left, just these numbers are easier to work with, it'd be +1. Right? So +1, if I plug it in, same there. Instead of being negative, it'd be positive. So really, we'd have 11 plus 16, +16, plus 3, or not. Yeah, it would be 11, because the 8, we'd still have 8. We'd still have 3. So this would just turn positive when 1 is positive. 27? So that's way up here somewhere, if we were using this graph. What that tells me is the behavior of the parabola is really steep. Getting very steep. This would probably need to be a little bit more like that. Who can tell me why it's so steep? What part of the quadratic makes it so steep? Yeah, the leading coefficient to the x squared. That is what makes it so steep. Sorry, I was like kind of pointing at the quadratic and it was off the screen. Yeah, the 8. This 8 is what makes it so steep. Questions on that? That is review of what we did yesterday. So again, you guys need to go watch the video. People who are green group, hopefully that makes sense. If not, please email me and let me know. Any questions from you guys? So the next thing we were going to talk about is I'm starting to see some mistakes from people when we look at things like this, because we're kind of stuck thinking about the rules that we've talked about, and we're not really like applying them. We're not continuing to think while we apply the rule. So go ahead and write this one down, please, if you would. And this is in that kind of perfect square form. (2x plus 3 squared). Now, when we've just been looking at like x plus 3 squared minus 4, if the 2 wasn't there, then we know our vertex is opposite of h and what k is. The question we need to ask here is, does this 2 impact where the vertex is? So how could we analyze, what could we use to investigate this together? A graphing utility, maybe? So something like Desmos, maybe? So you guys don't have to pull out Desmos, but what we just said is that if it was just x plus 3 quantity squared, so just x plus 3 quantity squared, then minus 4. Okay, we know that that would be opposite of h plus k. Boom. The question is, does putting a 2 in here, oh, yeah, definitely moved it. Why? Ellie? Come on. So if you're at all worried about the fact that I'm recording, the recorder doesn't pick up you guys because the mic is pointed this way. So normally we would have said the opposite of h, right? So that's where we get -3. And then what k is, and that's where we get -4. But in this situation, it is, so I'm going to write down vertex on your paper. It is the opposite of h, but it's divided by the coefficient in the parentheses. So if there's a coefficient outside the parentheses, it does not make a difference. Crap, that's only the x value. So it's -3/2, still -4, because that doesn't change, it's not impacted. But the -3 has to be divided by this coefficient. So if we want another justification of the one out front not changing it, if we put our 2 out there, it changes the steepness of our parabola, but does not change the vertex. A leading coefficient inside of the parentheses has to be the denominator of the opposite of h. Now, normally it's just 1, right? So that's why normally it doesn't matter, because normally it's just 1. So be careful. Vertex here would be -3/2 -4. Then we'd work it like the other ones. So let's set up an XY table, but this time, to get in a better habit, let's put -3/2 in like the middle of the table. Now we got to graph this. So again, you can be working from one set of axes if you want to graph all these on. I'm just going to draw new sets for them because it's just as easy. -3/2, so -1.5, 1, 2, 3, 4. There's my vertex. We know the parabola is going to point up because the coefficients to our x, or coefficients to our x squared really, are positive. This would end up 4x squared. So since we know it's going to point up, that's why I felt safe making my graph like this with space up here. Now, we don't have to use fractional values. So if I'm trying to go left or right from this point, in my mind, the easier direction to go is to the right because that's positive, and positive numbers are easier to work with. So pretty close to this point is an x of 0, right? That's not that far. Let's just use an x of 0. But 0 is going towards the positive. So actually, if we set up this table like we're used to, negatives would go this way. So 0, though, is 1.5 over. So we'd also have to go 1.5 over. That'd be -3 and then -4. And the reason that we use those numbers is -3 and 0 are equidistant from the -3/2. -4 and 1 are equidistant from the -3/2. We're keeping equal distances so that we can use that line of symmetry. Questions at this point? All right, try it. Try to derive some more of these. Plug in 0. So 0. I think I get 5. If x is 0, y is 5. And then symmetric to that, so when x is 0, y is 5, I got to go 1.5 over. So there's another good point we can use. Let's try +1. Right, +1 is still pretty easy to work with. So if x equals 1, then 2 times 1 would be 2. I'm going to go ahead and write that just because. 2 times 1 2 plus 3 squared. Ooh. It's going to get pretty big. Right? This will be 5 squared is 25 minus 1 is 21. Yeah, we can't really fit that. So if you want 5 points, if we can't fit 21 on our graph, what's another option? A half. Or if we want to go between the line of symmetry and a point that we've already derived, just to see like how quickly does it get steep, we could also use these x values, right? These are equidistant from that line of symmetry. So I could use -1 and -2, and those would be the same. So if we, I don't know, and again, our table doesn't have to be in order. If we use -1, okay, so if x was -1, 2 times -1, -2 plus 3 is 1, squared is 1, minus 4, 1 minus 4 is -3. So that tells us that these points exist really close to there. So now we can kind of draw, we have 5 points, and we always say that we need 5 points. Drawing the curve of the parabola is tough. It's something that I would use your pencil with and just try to draw small lines at once. Don't try to draw the whole line together. But we got 5 points, right? And that's all we need to graph, quote unquote. Questions on that one? Nothing. All right, we're going to go throw something off the roof. So let's say we're doing the pumpkin chunkin or whatever did we do that with you guys last year? The yeah. Yeah, you created like the protection devices or whatever you want to call it. I think in science, like we gave you a certain amount of balloons and stuff like that. So let's write down the things that we know in this situation. A ball is shot into the air from the edge of a building. You can think of this being our pumpkin if you want, but the building has an initial height of 50 feet. We're using feet. Come on, America. 50 feet above the ground, so initial height. So we're just going to write down what we know. Initial height. $50 feet. Initial velocity. Velocity is like speed, right? Is 20 feet per second. And the equation they give us can actually be talked about as h of t. And guys, this is where this gets so fun. I'm not like being sarcastic. This sort of stuff is really cool. This is how like when you see those like dude perfect things. Sorry, when I did the screen grab, there's like a little, the cursor was right here, and it looked really weird. So that's not a -20, that's just a positive 20t. Here's the really cool thing we're like able to do now. This trinomial they gave us is chock full of information. What is our C now? Don't just say 50, please. What does C represent in the context of this situation? Initial height, right? So, hold on, wait, that's height. So, h, right, if it's initial, it's when x is 0, right? B, our 20, what's 20 in this situation? Velocity. And this one's for all the marbles. I don't know why people want marbles, but it's for all of them. What's A? Anyone know what negative 16 per second per second? Why does something... I shouldn't throw the marker that I'm about to need. What brings that ball back down to Earth? Gravity. That negative 16 is gravity in feet per second. And it's actually per second. It's per second, or feet per second squared. So negative 16 feet per second squared is what we call gravity in America, but almost the rest of the world, if we were using meters, is negative 9.8 meters per second squared. So if you see negative 9.8 as a leading coefficient, you know that we're discussing things in meters. If you see negative 16 as a leading coefficient, you know that that is using our feet measurements. Oh, let's solve this. My bad. Didn't mean to move on. So if it's asking us, so we'll go deeper into the whole 16 versus 9.8. Those of you who are intuitive right now are thinking, but wait a minute, 9.8 meters and 16 feet aren't the same thing. We'll talk more about this another day. I'm like breezing over things pretty quickly. If you want to dive into it, you can find out that really 9.8 meters is 32. So there's like a justification why we're not using 32 right now versus 16. We'll get there. Right now, we just want to solve this because I don't want to go too deep with you guys. I already feel like a lot of times I'm going too quickly. If we want to know when does the ball hit the ground, when does the ball hit the ground? Okay, if I drew like a general picture, there's a building. We throw the ball at 20 feet per second. Gravity is pulling down at negative 16 feet per second, or whatever rate it's pulling down at least in the computation we've been given, we're using negative 16 here. We'll derive the exact y here at some point later. And we want to know, when does the ball hit the ground? What do we know about when the ball hits the ground? Yeah, h will be 0. Our output will be 0. And t, our x, will have some value. So we could find a vertex up here. And the vertex will tell us the highest point. But we want to know, when will the ball hit the ground? We want to know, okay, so when does this equals 0. How can we... Well, negative 16 is a perfect square. No. So we see perfect square. We see something with a factor of 4. Well, let's start playing with this in like perfect square terms. So I'm going to go ahead and cover this up because I think we know that information at this point. Trying to get some more screen. So I'm going to do this in pencil, just negative 4t squared will get negative 16t squared. Wait, crap, no, negative. Is there anything I could do to not have negative out here? What if I multiply everything by the opposite? So instead of having negative 16t, we would have positive. Instead of having positive 20t, we'd have negative. And instead of having positive 50, we'd have negative. If I do the opposite of everything, okay, what's the opposite of 0? Oh, well, that doesn't matter. So now 4t works. We would get 16t if we use 4t. We need negative 20. And guys, this is where sometimes, if we're thinking about perfect square, it's still good to write out both binomials. So we know 4t times 4t gets our 16t squared that we want. Negative 20. Well, if the outer and the inner are going to be the same, each of those should be negative 10t, right? So to get negative, what should 4 multiply by to get negative 10t? 2.5, right? So if we go 2.5 there, positive or negative? What else do we need to do? Guys, I'm trying to wait long enough so that you have time to think. We've done complete the square. Is this equation that we have necessarily true to the equation that we're building? Not necessarily, right? What is 2.5 squared? Actually, what we said yesterday, and I forgot you guys haven't necessarily watched that video, is instead of using 2.5, use the fraction 5/2. So I love what you just said. That squared is 25/4. So this, sometimes it's good when we have the binomial times binomial written out, will give us 16t squared minus 20t plus 25/4. You with me? So what do I do with this 25/4? If I come up here and I do the ignore it for a moment, I just add it to both sides. Or what we said was we can bring this over to the other side. So because I'm like out of paper, I'm going to grab another piece here. What if we make this negative 16t squared? Never mind. We had positive 16t squared, negative 20t, negative 50 equal to 0. We can rewrite this as 16t squared minus 20t plus 50. If we want to just get the open space for the constant on this side, we just said that the constant needed is 25 fourths. So we're going to add 25 fourths to both sides. This is now the left side is now the perfect square, and the right side is now well, this was, no, we don't know what the decimal for this is yet, so it really is 6.25. Yeah, that's 6.25, so we get 56.25. Right, because this, what's written in red, is 6.25. And that's what 2.5 squared is, 6.25. Is it? 2.5 squared is 5 halves. And that would be 25 over 4. Yeah, it must be. What do we do now? I think I'm going to need my calculator here in a second, so that's what I'm digging out. Unless I already got it out. How long are we in here? Oh no, I have to let you guys go in like 8 minutes. If we want the 0, all of this was getting the 0, right? Because we started equal to 0. We messed with it. Now we have 56.25 on this side. To get our zeros, we want to just solve this, right? Like solve this equation. So if we wanted our vertex, right? Because we're trying to see how we work real situations like this. If we wanted our vertex, we get our x from in here, right, opposite of the constant, divided by this coefficient, and the y would actually be the opposite of 56.25, right, because it's on the right side right now. So we talked about this yesterday, but we don't want the vertex. Sometimes we do. We want the highest point of the ball. We don't here. We want, well, wait, this would actually be the, remember how we made this whole thing the opposite of what it is? So if we think about this vertex, just note off to the side, since I went down that, and I think at least one of you will think about it. Negative 5 halves divided by 4 really multiplies for the opposite of that. I think, don't quote me on this, I think this becomes 5/8 and a negative 56.25. But this y value is actually the opposite of the problem that we have because we made everything the opposite. So you can't see where I'm pointing. When we made everything the opposite, we flipped this parabola over, so it's actually showing us the reflected parabola to make life a little bit easier for us. So in our real situation, this vertex is going to be at a height of 56.25, not negative, but just a positive height. But that doesn't matter. All right, let's get back to the thing that matters. Solving for this 0, we need a square root first. So if we square root both sides, and again, guys, some of where you might be feeling lost is if you didn't watch yesterday's video yet. So that will help a lot. 4t minus 5 halves equals positive or negative. Now, in this situation, we're only going to care about one of these, but we don't know which one yet. 56.25. What would we do next algebraically here? What would we do next working towards isolating the t? Get rid of the 4, get rid of the 5/2. Which one? 5/2 is easier to deal with first. So leave the 4t alone, and this will add to both sides. So we get a positive 5/2, or we could write it 2.5 if you want to at this point. Plus or minus radical 56.25. So the square root of this is actually not bad. So 2.5 plus or minus, you said it's what? And that's still equal to 4t though. So t would be equal to, set up a big old division, 2.5 plus or minus 7.5 divided by 4. In real world problems, we have to analyze, does a certain answer make sense in context? If we explore the negative route here, I'm going to get a negative amount of time. Well, that makes sense mathematically, that at some point, if this continued out here, that there would be another 0. But in the context of the problem that we care about, the only 0 we care about is the positive time. So the t that we want to look for is the plus. So 2.5 plus 7.5, well, that's 10. So 10/4 is 2.5. So if we go back to the initial, not even this trinomial, because this one was after we multiplied both sides by -1. If we go back to here, now either of these would work, but I'm just saying that what we wrote in green, ignore the orange, what we wrote in green is our original. If we plug in 2.5 seconds, that should, that should give us a height of 0. X or t, if we're using t in this situation, should equal 2.5 there. And h should equal 0, which is really our y and our x. Any questions on that? That took a lot longer than I expected, but that is fine because I've never taught like this before. The other stuff we were going to talk about today that we won't right now, we will next week. And actually, before we talk about next week, let's say 8th grade. I don't know if you guys know this yet, but your teachers are trying to plan like a field day for you. So while we still have nice fall weather, so I think Monday, Tuesday of next week is going to be a field day for you guys, and we won't have math class. So the next time we have math class, here's what we're going to talk about. And this is what's in your homework from this week. If you can't finish your homework this week because like you can't figure it out, it's okay that it's late, but you got to reach out and talk with me about it. So how do we graph all of these different forms, right? So we have regular factored out like binomial form. We have perfect square form with a leading coefficient on the outside. This is different than the first one we looked at today, right? Because that leading coefficient in this one, it's not a leading coefficient. It's just a coefficient to the x. It doesn't lead the whole problem. So how does that impact it? We have a trinomial completely written out with a negative coefficient, a negative b and a negative y-intercept. And then another trinomial written out, but factored, right, with a negative leading coefficient. So like the first one up here, but just slightly different. So that was the other review that we were going to do today, is how do we graph these? What do we know from each form? So really quickly, with like 2 minutes left, what do we know from this form? What does it tell us immediately, like right when we look at it? What do we know from a factored form parabola? Do we easily know the vertex or the zeros or neither? Zeros, right? This tells us the zeros, and we can center between the zeros to